Okay, so today we're going to be giving an introduction to stars. We're going to be going over the basic characteristics of them, so color, temperature, and magnitude, their definitions, and some things to keep in mind with some activities that we're going to be doing next. The first thing I want you guys to keep in mind as we go through this is what we know is based on what we observe. Any theory that we build in science has to be based on some sort of fact. Um, Trying to understand stars can be very difficult simply because stars are so old and it takes so long for them to change that we can't observe them changing. I'm talking about change over millions of years. It's kind of like trying to piece together the history of the Earth. It's not something that we can observe actively happening, and we have to find and create some other methods to try to understand it. Okay, so simple thought experiment. If you are, let's pretend you're walking through a garden and you see this beautiful butterfly fly past you, and let's say that you want to try to understand how the life cycle of a butterfly, how they're born, things like that. Are they born as butterflies? How do they work? Things like that. Pretending that we don't know anything about butterflies. And as you continue walking through this garden, you see all these different insects. You see these different stages. You see this little caterpillar walking, eating that, I don't know what that is, eating a plant. You see this little cocoon thing hanging from a tree, and then you see the butterfly, of course, flying through the air. If you continue to observe, what you'd eventually be able to do is you'd be able to discover patterns. So this is just the very simple scientific method of you observe, you organize the data that you observe, and you try to find patterns within that data. And so that's what we're going to be doing with stars. Now, in order to put together the life cycle of a star, understand how stars are created, we need to have data that we can observe. And so that's what this lesson is. It's going over the basic things that you need to know that you can observe, so that you can observe them. So just to reiterate, the most important part of this is the facts. What can we observe, and then trying to create some theories based on those facts. So the closest star to us is our sun. And even if you can look in the background of this picture, you can see all those little specks. And I just want you to visualize that each one of those specks is also a star. It looks like this. If we were to fly the millions of light years towards them, this is what they would look like, or something like this. They would be this big, fiery, burning gas ball thing. So, the first things that we can observe about our sun are color and temperature. Color, it's yellow, orange, reddish, and the temperature of our sun is about 27 million degrees Fahrenheit. So these are characteristics that we can observe pretty intuitively, but how would we define color and temperature? Color is really hard to define. The technical definition would be an object bouncing light onto your eye. Something along those lines. And what that means, we can imagine, so in this diagram, the sun is in the top left corner, there's an apple, and there's you. The sun is giving off light, and that light is hitting the apple, bouncing off the apple, and reflecting to your eye. That's basically what color is, the technical definition of color. Temperature is a little bit easier. Temperature is heat created by an object. It's measured with a thermometer or felt by touch. Temperature is something that is easier to define because it's something that we can observe from a very young age. Okay, so now that we've defined these two characteristics, can we find ways that they relate to each other? How do color and temperature relate? So this is something that you might know more intuitively, but color is based on temperature. So if you think of a lighter, for example, the hottest part of a flame or a fire is going to be the blue part. The blue part of the flame is the hottest part. Maybe that's something you knew, maybe it's not. But in the same way that the white part isn't as hot as the blue part, and so we see this relation between color and temperature, we can see that in stars as well. So on the left we have this more a reddish kind of sun or star, and then we have a yellow star, and then we have a blue star. And believe it or not, those white specks that you see up there, some of them are blue stars. That seems like a really weird thing, but that's how it is. So between these three stars, which star would you expect to be the hottest? It would be the blue star. And if you look at the graphs, I know the graphs above them are a little bit confusing, but if you look at the graph on the very far right, it says 18,000 Kelvin is the average temperature. So compared to the 5,800 Kelvin or 2,500 Kelvin, the blue star is definitely going to be hottest. Okay, so those were the most important parts of color and temperature. And the next characteristic is magnitude. Magnitude is just a fancy big word for brightness. So the brightness of a star. The definition for magnitude, or brightness, would be how much light is given off. So if we look at this really crazy video thing here, the brightness or the magnitude of this star is increasing for some reason, whatever reason, but this is just understanding what magnitude is. If we look at this picture right here, looking at all the different stars, some of them are brighter. So some of them have a higher magnitude. And the first question, of course, would be why are some stars brighter than other stars? The first and easiest reason is because some are different sizes. Imagine we have a little flashlight versus like car headlights. Which one is going to be brighter? The car headlights are going to be brighter because they're way bigger than a flashlight, unless you have some crazy flashlight. But we're not going to worry about that. So headlights are bigger, brighter, therefore they're brighter. So the other reason why a star could be brighter, actually, first I want you to imagine, like, look at this picture. This picture of our night sky almost looks like there's a blanket above us. It looks like a 2D kind of image. And in reality, our universe is a three-dimensional thing, right? So instead of thinking of our stars and our universe like this, think of it like this crazy mess. So look at this. We have a three-dimensional cube, this box, and inside there are all these different specks. Each of those specks, imagine, is a different star. Okay? And just for the sake of argument, we'll pretend that we're at the very center of that sphere, and the universe is the rest of everything around us. So when we look out into the sky, we could see that diagram on the left. It looks like our stars are all on the same plane, but they're not. Some of them are much, much further away than others. So let's pretend we have these two stars, A and B. We're looking into the night sky and we see this star A and star B. And it looks like they're the same size. It looks like they would be the same brightness. But what if star A was actually a lot bigger? Why would it look the same size and the same brightness? Well, the only way that it could do that is if it was much, much further away from Earth than star B was. So imagine if you're comparing the headlights versus the flashlight. If someone's, got their headlights on, but they're half a mile away, versus someone who's got a flashlight that's a couple inches from your face, the flashlight's going to look a lot brighter. Distance plays a very large role in how bright stars look. So this is the magnitude, the brightness. This is based on size and distance of stars. So if we look here, this is a diagram of the Little Dipper. These are the different stars in the constellation, the Little Dipper. And looking at them, you can see that some of them are a little bit brighter. Polaris is the brightest. And so each of these stars has a different magnitude. And that magnitude, that difference in brightness, is in part because of their size, but also in part because they're all different distances from us. So if we were to take that diagram, instead of it just being that blanket, so in this diagram, Earth is in the bottom left corner, and then that purple-looking blanket thing, that's kind of that blanket that we see in the night sky. And it looks like all the stars are on that blanket, but in reality, the stars are much further away. Some stars are going to be a lot further. So this is actually the constellation, the Big Dipper now, but it kind of gives you a visual of how each of these stars is in a different place. So now we have two different definitions of magnitude. We have an apparent magnitude and an absolute magnitude. On the left, we see a star with the purple arrows. That's the apparent magnitude of the star. So if we just look out into the night sky and we see a star, that's how bright it looks from Earth. That's apparently its brightness, its magnitude. Now, if we were to move all of the stars in our universe to the same distance away, that would be their absolute magnitude. This is really important for science. If we want to eliminate variables, if we want to try to compare brightness and size and temperature and color of stars, we can't have them at different distances. So we'd have to have a way to simulate them being all the same distance so that we can actually compare their brightnesses. We can actually compare their temperatures and their colors. So absolute magnitude is very important, and that's what we're going to be using as we go forward. So again, apparent magnitude is the actual magnitude, the actual brightness of a star from Earth, and absolute magnitude is the magnitude or the brightness of a star from a standard distance. So if we were to look at this constellation on the left is the apparent magnitude. So that's how the constellations and those stars actually look in the sky. And on the right is their absolute magnitude. So if we moved all of those stars in their position, just theoretically, and we were to place them exactly the same distance away from us, the picture on the right is what those stars would actually look like. So the three characteristics that we were really looking at, the three vocabulary terms, are color, temperature, and absolute magnitude. We want to take these terms, we want to apply them, we want to try to observe these stars, organize our stars using these terms, these methods, and then try to establish patterns in the stars we see to understand their life cycle and understand more about them. Thanks.